For any help regarding statistics exam help, visit https://www.statisticsexamhelp.com. Email support@statisticsexamhelp.com or call us at +1 678 648 4277. Problem 1. Prove that for all n, the following identity holds solution. By induction on n greater than or equal to 1, with induction hypothesis for all n. Statistics exam help problems and solutions. Base case n equals 1 inductive step, assume Pn, we need to show that Pn plus 1 holds. Statistics exam help. As required. We have shown that Pn plus 1. Thus, Pn is true for all nn. Problem 2. Coin flip is a two-player game. Each player wins with probability exactly 0.5. There are no ties. N people are playing a coin flip tournament. Every person plays a coin flip game with every other person exactly once. Thus everybody plays n-1 games. The outcomes of all the games are mutually independent of one another. We say that the tournament is a success if for every I, 0, 1, n-1, there is exactly one player, which we will refer to as pi, with exactly I wins. A. Prove that if the tournament is a success, then for any integers j, k with 0 less than or equal to k less than j less than or equal to n-1, pj defeats pk. Statistics exam help. B. What is the probability that the tournament will be a success? C. Show that your answer to part B is 1. Solution. We have statistics exam help, which for sufficiently large n is clearly less than any positive constant and thus is 1. Problem 3. A person is passing time by advancing a token on the set of natural numbers. In the beginning, a token is placed on 0. The person keeps playing moves forever. Each move proceeds as follows. 1. First the person tosses a fair coin, with heads/tails equally likely. 2. Suppose the token is currently placed on n. If heads came up, then the person moves the token to n+3, otherwise he moves the token to n+4. For each nn, let n be the event there was a move on which the token landed on n. Let Pn. Statistics exam help. Equals Prn. Find a recurrence relation for Pn. You do not need to solve the recurrence, but you should specify the boundary conditions that would be necessary to find a solution to the recurrence. Problem 4. Exactly 1/5 of the people in a town have beaver fever copyright. There are 2 tests for beaver fever, test 1 and test 2. When a person goes to a doctor to test for beaver fever, with probability 2/3 the doctor conducts test 1 on him and with probability 1/3 the doctor conducts test 2 on him. When test 1 is done on a person, the outcome is as follows. If the person has the disease, the result is positive with probability 3/4. If the person does not have the disease, the result is positive with probability 1/4. Statistics exam help. When test 2 is done on a person, the outcome is as follows. If the person has the disease, the result is positive with probability 1. If the person does not have the disease, the result is positive with probability 1/2. A person is picked uniformly at random from the town and is sent to a doctor to test for beaver fever. The result comes out positive. What is the probability that the person has the disease? Solution. Let B be the event that the person has blah. Let T1 be the event that the person is tested with test 1. Let T2 be the event that the person is tested with test 2. Let P be the event that the test comes out positive. A tree diagram is worked out below with the given information. Statistics exam help. The probability that a person has blah, given that the test comes out positive is. Statistics exam help. Problem 5. Two identical complete decks of cards, each with 52 cards, have been mixed together. A hand of 5 cards is picked uniformly at random from amongst all subsets of exactly 5 cards. A. What is the probability that the hand has no identical cards, i.e., cards with the same suit and value? For example, the hand Q heart suit, 5 spade suit, 6 spade suit, 8 club suit, Q heart suit has identical cards. We can calculate this probability by computing. There are 104 cards. There are 5 cards in a hand. Order does not matter. The total number of possible hands is, there are 52 possible card faces, and we can choose 5 of them if no identical cards are allowed. Statistics exam help. Additionally, each card can be from either deck 1 or deck 2. Therefore, the number of hands with no identical cards chosen from 2 decks is. Therefore, the probability of drawing a hand with no identical cards is. B. What is the probability that the hand has exactly 1 pair of identical cards? This can be solved by a similar approach. A hand of this type can be distinguished by the face, suit and value, of the repeated card, and by the faces of the 3 non-repeated cards. There are 52 possible values for the face of the repeated card. Statistics exam help. Problem 6. 28 points, scores for a final exam are given by picking an integer uniformly at random from the set 50, 51, 97, 98. The scores of all 128 students in the class are assigned in this manner. For parts A, B, C, and D, you may not assume that these scores are assigned independently. For parts E, F, G, and H, you may assume that these scores are assigned independently. A. For I, 1, 128, what is E, C? B. Show that E, S equals 74. Make no independence assumptions. C. Prove that. Make no independence assumptions. D. Improve your previous bound by using the fact that the minimum possible score is 50. Statistics exam help. Prove that. Make no independence assumptions. E. For the remaining problems, assume that all the scores are assigned mutually independently. Use problem 1 of this final to find VAR, C. F. What is VAR S? G. What is the standard deviation of S? H. Prove, using the Chebyshev inequality, that. Solution. A. We simply take the average of the numbers from 50 to 98. Thus, E, C equals 74. B. By linearity of expectation. Statistics exam help. C. By Markov's inequality. D. We define a random variable t equals s minus 50, and thus E, t equals E, s, minus 50 is equal to 24. Now we just apply Markov's inequality. E. We define t equals c minus 50. Statistics exam help. G. The standard deviation of south is simply the square root of the variance of s. H. Using Chebyshev's inequality. Problem 7. 1000 files F1, F2, F1000 have just reached a disk manager for writing onto disk. Each file size is between 0 megabytes and 1 megabyte. The sum of all file sizes is 400 megabytes. The disk manager has 4 disks under its control. For each file phi, the disk manager chooses. Statistics exam help. A disk uniformly at random from amongst the 4 disks, and phi is written to that disk. The choices of disk for the different files are mutually independent. A. What is the expected number of files that will be written to the first disk? We can use indicator variables. For each file, pi equals 1 if phi is written